Hello, welcome back, you wonderful people. Today we're going to look at this graph. We're going to analyze this graph, and we're going to analyze that using calculus. And there are three things we need to deal with. That is, first, we need to find out the x-intercepts of this function. It's a polynomial function, specifically is a cubic function. The next one is we need to find critical points using the first derivatives, and that way we can find the certain curvature of the polynomial function, and then based on that we can find the behavior of the graph within the domain intervals. All right, let's go ahead and do that. The first thing, we're going to find x-intercepts, and that is quite straightforward. So you just have to set that equal to 0, and then set the function 0 equal to y equal to 0. Okay, and we are just going to use simple factoring, and the best thing to do, GCF is x squared, so that would be minus x plus 2, set that equal to 0, and in here we notice that two solutions, x equal to 0, x equal to 0. You can write it twice, or you can just make a mention of that. That is actually a double 0. And then the next solution, or x is equal to 2. So we have two point of intersections, x-intercepts, but one of them, 0, 0, is the same. That means the graph is touching that point, the x-axis at 0, and then it bounces off of the graph. Now, based on the analyzing of the cubic function, we know that you can graph this freestyle or using techniques that are not necessarily using any calculus tools. We can also use the graphing techniques of polynomial functions general, and then we go from there. Next step now is we go ahead and find critical points using the first derivative. So now I need you to consider the derivative of the function, so dy dx. So this is the second, this is part one that we just finished. Now it's part two. We need to consider dy dx of the function. That means the derivative of that function. That becomes minus 3x squared plus 4x. Okay, so this is the derivative, the first derivative of that polynomial function. Now remember, the derivative of a function is the slope of a tangent line to the curve. All right, now if we want to find the critical points, you need to set that equal to 0. That means the slope is 0. The slope of the tangent line is equal to 0, and therefore we need to solve for values of x. Okay, and then when we do this, let's solve this. So we have 0 is equal to, and then we just do a simple factoring again to solve this quadratic function or quadratic equation. I'm rewriting it in a way that we can see it better. All right, so here you go, x times 4 minus 3x equal to 0. All right, and then in this case we have x equals to 0 or x is equals to 4/3. So we have two critical points. CP for critical points. Great. Now that we have the critical points, we need to find out exactly what the y value is for each one based on when the x is given by 0 or 4/3. Okay, so now let's go ahead and plug these x values separately into the original function right up here, minus x cubed plus 2x squared, and find out what the y coordinate is, and then move on from there. Okay, let's do that. So here we go. I substituted x0 to the original function, which is right here. We get y equal to 0. So we know, so in the first part right here, y equal to 0. So this is actually 0. We know that. Next one, x equal to 4/3. We plug it back into this equation, right? Actually, it's function. We're going to find what y is, and y is 32/27. We just direct substitution and do the math in here, and then that's what you will get, 32/27. So that's what we have. We have this is y is 32/27. Okay, very good. Now that we have this, now we need to go ahead and analyze the graph between the intervals. Let's consider each of these values and go through. So first consider what happens to the function on either side of each critical point. Remember the critical points, we got 0, 0 and 4/3 and 32/27. There are two critical points. So what happens if when x is less than 0? So what happens, let's say x is -1. When if that's the case, what happens to the derivative? Let's go back to the derivative. This is derivative right here. We have the derivative, -3x squared plus 4x. Well, when x is -1, this would be -4, -3, that would be -7. The value, so so f prime of 1, or -1, sorry, that is equal to -7, which is less than 0. And if the first derivative is negative value, that means that the slope is negative. That means the graph is a decreasing graph in that region. That means the curve is decreasing, okay? So that means the graph is coming down, the curvature is coming down. What happens when x is greater than 4/3? Okay, so let's suppose that x is just a simple value 2. Well, the derivative of the derivative when x is 2 is negative as well. So it would be 8 minus 12. That would be 0 or less than 0 because it's -4. So we know that the graph again, so the slope is negative. And if the slope is negative, that means again, the graph is function f of x, or the graph is decreasing. Okay, so that's very good. So so the graph is also decreasing at the end part of the value. So before value, the first critical value, the graph is decreasing, coming down. After the second critical value is coming down. Now let's look at in between the values. Okay, so what happens when x is between 0 and 4/3? Let's suppose x is 1. If that's the case, f prime of 1 is 4 minus 3, which is equal to 1, which is greater than 0. That means the slope is positive, and a function f of x is increasing. That means it's upward curve value. All right, okay, create a nice chart in here. So for the simplicity, so that we know what happens. So here it is, that's the chart that we have. We have f prime of x, and we have f of x, or y. So when the slope is negative, or the derivative is negative value, that is before the first critical point, if it's smaller than 0, the graph is in a downward motion. Then at critical point, we have 0, which is the minimum. Then between the two critical points, we have another critical point there, which is 4/3. we have positive. That means the graph is in upward motion because the slope of a tangent line is positive. And then when the value is again negative, the value, the first derivative after this second critical point, we plugged it in, and notice that the graph is decreasing again because the slope is negative. Okay, so based on that, we can now sketch the graph. So let's do the sketch. So when you graph the critical points 0, 0, and we have the second critical point 4 third and 32 over 27, and this is the approximation. We have the two intercepts 0 and 2, and those are the x-intercepts that we found. In fact, in here we have double 0 because it's touching the graph, the polynomial, and bouncing off. At the critical points, we have the tangent line. There are horizontal tangent line, right? So if I can draw this properly, like let me just do the tangent line. So this is the tangent line right there. That's slope is 0, and so is here. So which is actually the x-axis. This is another one. Slope is equal to 0. All right, so this is how you analyze a graph and therefore graph it accurately. And of course, if you want to make it very accurate, you have to actually choose some other also points, plot those points and make a table of values within the intervals that you have before the critical points, few points here on this side to the left of the first critical point, and then a couple of points between the two critical points, and then after as well. And then you can graph it much more accurately. Or the other part of it is that once you have done all of that and sketch it, in order to make it fully accurate and 100% accurate, then you have to use one of the graphing function tools. So it requires many steps, and in each time that we go through it, we have to make sure that we're doing it properly, and we have to write every single thought process down so that we know what we're doing and we show all our work. All right, be well until next time. Keep at it.